Mathematical definition of the limit. What is the mathematical definition of the limit? Its statement says that let f of x is a function defined in an open interval except the exact value of c. Then the limit of f of x is L as x approaches c. The statement says that if f is a function which is defined in an open interval except the exact value which is c is the exact value except this exact value, then the limit of f of x is L as x approaches c. Normally in the limit, what we do here, we don't care about the exact value. We only care the nearest point where we approached. F is my function, suppose, which is defined in an open interval, except the exact value of c. In other words, I can say that f is a function which exists in an open interval except the exact value which is c. That is an open interval where this f exists everywhere except the point c. If such is the case, then the limit of f of x will be L as x approaches c. This L will be my limit as x approaches c. Now one thing is very important to be noted. Normally in the limit, we don't care about the exact value because it may not be possible to touch the exact point. In the limit, we normally approach it closer and closer to the exact value. So c is my exact value. I don't care about the exact value. I just care about the nearest point where I approached. So I'm getting closer and closer and closer, which approximately equals to c. So if this is the case, then the limit of f of x will be L. So L will be my limit as x approaches c. In simple words, I can say that these approaching things that we do for the c, we approach c, x approaches c to the nearest point. So that will be my L. That's what limit means. In formula shape, I can write limit of f of x equals to L. As x approaches c, L will be my limit. F is a function which is defined in an open interval except the point c. Where x approaches c, we are approaching c. We are not able to touch the c, but we are approaching. We are getting closer and closer to the c, to the nearest point, which equals to limit. This phenomena is called limit. This stuff, this thing, this logic is called limit. That's what limit means. So I can say that for every epsilon value where epsilon is greater than 0, there exists delta value. Therefore, if modulus x minus c is greater than 0 and less than delta, then modulus f of x minus L is less than epsilon. For every epsilon value where epsilon is greater than 0, there exists a delta value. Therefore, if modulus x minus c greater than 0 and less than delta, c is the exact value. Modulus x minus c is greater than 0 and less than delta, then modulus f of x minus L is less than epsilon. These are the two conditions in mathematical definition of the limit. What is epsilon? What is delta? Let me show them graphically. This is my xy plane. Here is my function. It is a random function. If x is the exact point which is c, c is the exact value. So the function f of x will be defined in an open interval. The region inside the two blue lines is the specific interval where the function is defined except the point c. Let's say the region along y-axis is my epsilon. This place along the y-axis is called epsilon. This region along x-axis is called delta. These are my epsilon and delta. I want to approach the exact value which is c. How I'm going to approach it? I'm going to approach it from the two directions. I'm going to go downward and also upward. Similarly, along x-axis I can approach from the left side and also from the right side. The two conditions say that if modulus x minus c is greater than 0 and less than delta, this is my delta, which means that I can approach c either from left side or from right side. That approaching must be less than delta. It should be within the specific delta region. It must be less than delta, but should be greater than 0. This whole region is my delta. Then modulus f of x minus L is less than epsilon. This is my epsilon. This condition applies here along y-axis where I can approach from downward and upward, but must be less than epsilon. This is my epsilon. This whole region is called epsilon. Let f is a function which is defined in an open interval. What does that open interval means? This is my open interval. This whole region is my open interval. F is defined in this region except the point C. Accept this exact value. Accept this value. It is defined everywhere in this region. As x approaches C along x-axis, I'm gonna get the limit L here along y-axis. That's what this statement means. For every epsilon value where epsilon is greater than 0, there exists delta value. Therefore, if modulus x minus c is greater than 0 and less than delta, then modulus f of x minus L is less than epsilon. Epsilon is this whole region between these two blue lines along y-axis. The region from here up to there. This is my epsilon. I just gave the name epsilon, which is greater than 0. This region is greater than 0. There exists delta value. For every epsilon, there exists delta value. They are interrelated with each other. They depend on each other. The region from here up to there between these two blue lines is my delta. This region is my delta. So for every epsilon which is greater than 0, there exists delta value. Modulus x minus c. X minus c is that c is my exact value. I want to approach c. I can approach this value from both the sides, either from left side or from right side. Let's suppose if I want to approach it from left side and going all the way to the nearest point. Now at this point I am very close to the point C, but it is not actually point C. Approximately it is point C, I can say, but exactly it is not C. Look, x is the distance along x-axis here. So this region, this interval is my x. This is my x. What I'm gonna do here, I'm gonna subtract the c from the x value. The function is defined everywhere except the exact value which is c. So I'm gonna subtract c from my x. So modulus x minus c must be greater than 0, but should be less than delta. If such is the case, then modulus f of x minus L is less than epsilon. This is my f of x. Look, f of x, what is f of x? F of x is my y value. This is my y. I can also say that y minus L. So this statement belongs to x-axis. This statement belongs to y-axis. X minus c is that I'm gonna subtract the exact value from x along x-axis, but must be greater than 0 and less than delta. So if such is the case, then modulus f of x is y, like y minus L must be less than epsilon. So at the end, what I got from mathematical definition, I got that if modulus x minus c is greater than 0 and less than delta, delta is here. This is my open interval. The region within these two dotted lines is my interval. The function defines everywhere except the point C. Therefore, I have x minus c. Then modulus f of x minus L is less than epsilon. This is my epsilon. So that was the mathematical definition of the limit. I hope you understood it. Let me give you one example based on mathematical definition in upcoming lecture.